Welcome to example 4. We have a projectile motion problem involving a baseball being hit with an initial speed of 37 meters per second at an angle of 53.1 degrees. We are asked to find a variety of things such as position and velocity at t equals 2 seconds, and the time that it takes the ball to go to the top of the path, and the horizontal range from the beginning all the way to when it hits the ground again. So we'll first start off by doing, and it's actually been done for you, is draw a picture. So whenever you have a problem like that, I would draw a sketch of the path of the projectile. I would select an appropriate coordinate system. You can see there's the x and y axes here. And label the important information that you know of. So for example, we have the initial vertical velocity and horizontal velocity that we need to find. And then at the top of the path, we know that the vertical velocity is 0. And then later on, some distance when it hits the ground. So let's go ahead and find the initial and horizontal velocities. That's one of the things I would do before I start to solve the problem, because that's kind of like the known information. So the v0x, the horizontal velocity initially, is the velocity of 37 meters per second times the cosine of the angle, which is 53.1 degrees. So if we sub that in here, we have 37 meters per second times the cosine of 53.1 degrees. We'll get a velocity of 22.2 meters per second. Then we'll do the similar thing for the vertical velocity, v0y, which is equal to v0 times the sine of the angle theta 0. That's 37 meters per second times the sine of 53.1 degrees. And that will give you a velocity of 29.6 meters per second. So now what I'll do is I like to organize my given independent from each other so that you don't mix up the horizontal and vertical known information. And so now I'm going to include all the initial and final, if I know that, positions, velocities, and accelerations. So we know the initial position is 0 meters, and the initial vertical position is 0 meters as well, because we've made our origin right here at that point. We know the initial horizontal speed is 37 meters per second, and the initial vertical speed is 29.6 meters per second. Oops, I just realized it's not 37, it's actually 22.2. And we know the horizontal acceleration is 0. It's always 0 meters per second squared in these projectile motion problems. And the vertical acceleration is negative g, or negative 9.8 meters per second squared. So now let's look at the question. The question is asking, find the ball's position and the magnitude and direction of its velocity when it's at t equals 2 seconds. So we're looking for x and y at a time of 2 seconds, and the vertical velocity and the horizontal velocity at that point. I'm not sure exactly where it's going to be on this curve, but we do know we have some equations that describe the horizontal position and the vertical position and the horizontal and vertical velocities. So we're going to start off here by writing at t equals 2.00 seconds and sub in that time into our known equations. You can think of the equations as functions. So let's start with the horizontal equation. That's x equals x sub 0 plus v sub 0 x t plus 1/2 a x t squared. But we know that the acceleration horizontally is 0, and we also know that we set the origin where at x sub 0 to be 0 as well. So now we substitute in here, and we get x equals 22.2 meters per second times 2.00 seconds. And that will get you a horizontal position of 44.4 meters. So now let's solve for the y vertical distance. Y equals y0 plus v0yt minus 1/2 gt squared. Now I've already modified it because I know that the acceleration is negative g. Instead of putting plus 1/2 ayt, I just put in a negative g in for ay. So now let's cancel out the vertical initial position because we're starting it from the origin once again. So we have y equals 29.6 times 2 minus 1/2 times 9.8 times 2 squared. And that's going to give you a distance of y equals 39.6 meters. So now let's find the horizontal speed and the vertical speed. The horizontal speed is equal to v0x plus axt, but remember that the acceleration horizontally is 0. So really, the horizontal speed is the same as the initial horizontal speed. So it's 22.2 meters per second. The vertical velocity is given by v0y minus gt. I'm using v equals v0 plus at and replacing the a with negative g. And so that's 29.6 meters per second minus 9.8 meters per second squared times 2 seconds. And that will give you a velocity of 9.99 meters per second as the vertical velocity. We're also asked to find the resultant of that velocity. So we know it goes 22.2 meters per second to the right and about 10 meters per second upwards. So we want to find the resultant of that velocity, and we're going to use Pythagorean theorem, Vx quantity squared plus Vy quantity squared. So that is the square root of 22.2 squared plus 22.2 and 9.99 squared. 9.99 squared. And we'll get a velocity of 24.4 meters per second. And the angle can be determined by using the arctan of Vy over Vx. So the arctan of 9.99 all over 22.2, which gets you an angle of 24.2 degrees. And that is above the x-axis. So let's show that actually up here. You can take a look at it. It is roughly around here. We have a horizontal velocity, Vx, of 22.2. We have a vertical velocity of Vy of 9.99, and then the resultant velocity of 24.4. And then this distance here is the y distance that we just found, which was 39.6 all the way down to the ground here. And then this distance here is the horizontal distance that it went along the ground. So let's now move on to part B, and we're asked to find the time it takes to reach the top of the path and the vertical height h here at that point in time. So you'll notice that I've written one really important piece of information, and that's the vertical velocity to that point is 0 when we get to that time t1. And we're going to use that to find the time and height. If you didn't know that, you would have a very difficult time finding B. So here we go for B. We're going to use the velocity in the y direction equals the initial vertical velocity minus gt to solve for that time at 1. We have 0 for the velocity at the top of the path. The initial vertical velocity was given as 29.6 meters per second minus 9.8 meters per second squared times t sub 1. And that will get you a time of 3.02 seconds. Now we can go ahead and plug that into our vertical distance equation. Y equals y0 plus v0yt minus 1/2 gt squared. So therefore our maximum height will be equal to, well, this is 0 because we're setting it at the origin once again. So 0 plus that initial vertical velocity, which is 29.6 meters per second times 2 seconds minus 1/2 times 9.8 meters per second squared times 2 seconds quantity squared. And I just realized actually it should be 3.02 seconds in each of these areas. It's definitely Friday for me. So subbing in appropriately the right time of 3.02 seconds, you'll get a maximum distance of 44.7 meters. That's the vertical distance, or for the maximum height. Okay, let's go look at part C now. And we're asked to find the horizontal range, that's R in here, from the starting point to when the ball hits the ground again. There's several ways to solving this, but I'd like to use the information I just got from part B. I know the time that it takes to get to the top of the path, and I also know that this path is symmetric, so that the time up is also the same as the time down. It means I really know the time for the entire path from the beginning to where it hits the ground again. It should be double the time to get to the top of the path. So let's use that in our solving for the horizontal distance, range r. So part C, the total time in air, t2, would be equal to the time up, t1, multiplied by 2. So that's 3.02 seconds times 2, which gives you 6.04 seconds. Now we're going to use that to find the horizontal distance. X equals x sub 0 plus v sub 0 xt plus 1/2 axt squared. There is no horizontal acceleration, so that disappears, that term, and there's no horizontal initial position, that disappears as well. So r, which is the range symbol, is equal to the horizontal speed, which was given as 22 meters per second, if you recall, and that multiplied by 6.04 seconds. And we'll finally get a range of 134 meters. And that's it for this long problem. Have fun with WebAssign.